This video is sponsored by
DFRobot.
Hello YouTube and welcome to Heathen Hacks. If you're here from the previous video, glad to see you back. I assume that you've just finished project number 11. If so, let's move on to project number 12 or RGB controller. This is really similar to my WS2812B RGB LED brightness control and color mixing project. Check it out right here if you want. But instead of using a WS2812B RGB LED chip, for this project, we would use a normal RGB LED diode. Let's go! Here are the things that we're going to need for this project: the DFRobot board, prototyping shield, male-to-male jumper cables, 220 ohm resistors, 10k ohm potentiometers, and lastly, a 5mm RGB LED. Moving on to the wiring phase, first, we need to get our DFRobot board, mount the prototyping shield on top of it, connect our three 10k potentiometers right here, here, and here. Each of these potentiometers would control each of the colors inside our RGB LED diode, one for red, one for green, and one for blue. Attach our RGB LED while keeping in mind that the LED's cathode or the longest leg is on the right side. After that, let's connect our 220 ohm resistors right here, here, and here. Remember to leave a space here for the ground pin connection later. I have prepared a few jumper cables for the potentiometers and RGB LED's data, 5 volts, and ground connections. First up, let's start with the blue jumper cables. Let's connect our potentiometers data or Vout pins to their corresponding analog pins on the DFRobot board. Starting with the first potentiometer on the left side, this one should be connected to DFRobot's analog pin number 0, second potentiometer to analog pin 1, and the third one to analog pin number 2. Moving on to the black jumper cables for the ground connections, connect the RGB LED's cathode to ground first, followed by the potentiometer's ground pins here, here, and here. Do take note though that it doesn't really matter if you connect the ground or 5 volt supply here or here, because potentiometers are not polarized, and the only thing that it would change or affect is on what direction we twist the potentiometer's knob. For example, when the knob is turned all the way to the right and your 5 volt supply is connected to the third pin of the potentiometer, which is on the right.
Wait a minute!
I feel like we've discussed this already on project number 11. Yeah! Alright, I'm just gonna skip this example then. Next are the red jumper cables for the 5 volt supply here, here, and here. And then lastly, the green jumper cables for the red, green, and blue pins of the RGB LED. First pin of the LED from the left side is red and is connected to DFRobot's digital pin number 9. Third pin is blue and is connected to DFRobot's digital pin number 10. And fourth pin is connected to DFRobot's digital pin number 11. That's it! Alright, now let's connect our board to the computer. Here's the sample code that DFRobot has provided. Make sure that the MCU is being detected and we're on the correct port. Click on verify, then upload the code. Here we can see that the serial print function is present. That means that things would show up on the serial monitor. So let's launch it. And there it is. The values from the 3 potentiometers are being shown. Hold on, let me turn off some lights. Now let's change the value of red and green to 0 by turning the potentiometer all the way to the left. And now we're left with just blue. See? Alright, I know what you're thinking. It looks like I'm turning the potentiometer knobs to the right even if I'm saying the opposite side, right? But it only looks like that, because the 5 volts and ground pins of the potentiometers are at the back and the analog pins are at the front side. The color that the RGB LED is showing depends on the values from the potentiometer. For example, if I increase the value of red to 255 and decrease the value of blue to 0, it would make it show red. Decrease the value of red to 0 and increase the value of green to 255 and it would make it show green. Well, you get the gist. We can use the potentiometer to mix colors. That's it. Here's how the code works. Well, I'm not really sure if I should explain anything. I mean, the code is pretty much just a combination of lines of codes from previous projects, except for the constraint function. But here's a quick rundown of it. So we declare everything first, set up the RGB LED pins using pin mode, begin the serial communication to use the serial monitor, convert the voltage values from the analog pins to analog using the analog read command, map the converted values and then store them using these variables, print the values stored on the variables to the serial monitor using serial printline function. Then configure the analog values for the RGB LED using the color RGB function. Color RGB function has 3 parameters: red, green, and blue variables. Inside this function, we have another familiar looking code called analog write, which would be used to transfer or write the values from the variables that we have used to store the mapped values from the analog read earlier. We also have included a constraint function to constrain the values to be within a range. The constraint function has 3 parameters: the number to constrain, which can be a variable, the lower end of the range, and the upper end of the range. So on this line of code, we first write the values that would come from the color RGB function inside the void loop, and then constrain them using the range of 0 to 255. That's it! I know that it can be quite confusing, so for a more in-depth explanation, please refer to the PDF. Click right here if you feel ready to move on to the next project. See ya!